In Chapter 15, we're going to talk about a few characteristic reactions of carbonyl compounds, and creating alcohols is the first topic. Those can be made by substitution reactions involving alkyl halides, but alcohols can all be made by starting with other oxygen-containing organic compounds, and we'll see how that works. We'll talk about what esters are. Esterification is the creation of these esters, and it involves carboxylic acids as well as alcohols as well. So we'll start with reduction and compare that to oxidation. These are two big types of processes in chemistry in general and also organic chemistry. You can see oxidation isn't just the gain of oxygen as you might expect. It can simultaneously involve either gaining oxygen and or losing hydrogen atoms from a molecule, and we'll see some examples of that has the effect of interconverting some of these carbonyl compounds and in some cases creating alcohols from them. Reduction is the opposite process. It can be thought of as reducing the numbers of oxygens, but as it says there, it also sometimes involves the gain of hydrogen. So it's always the fate of either oxygen or hydrogen, and whether they're being gained or lost during a chemical reaction, that kind of determines whether something qualifies as oxidation or reduction. And here's some examples of oxidation reactions. Aldehydes can be converted to the corresponding carboxylic acid by gaining an oxygen atom. We can start with alcohols and cause them to lose a couple of hydrogen atoms and create a corresponding carbonyl compound. You can see in this second case here we're creating an aldehyde from an alcohol, and sometimes that aldehyde will continue to oxidize and become the corresponding carboxylic acid like we see up top here. That last reaction doesn't involve oxygen at all, and yet it can be classified as oxidation because it is a loss of hydrogen. That happens when alkanes are turned into the corresponding alkene. So that is another process that we've seen before. We just haven't referred to it as oxidation. But now we can kind of incorporate it into this general idea. Reduction here, well, it's just the opposite. So I literally took the products from that last slide, made them the reactants, and just essentially reversed the process. And in real life we can do that. We can take acids, remove hydrogen to create corresponding aldehydes, or reduce it all the way down to the alcohol as it shows in that second reaction. And again, we don't have to have oxygen at all to talk about reactions like reductions, because when we do hydrogenation in that last reaction there, adding hydrogen to an alkene, because that involves a gain of hydrogen, that also qualifies as being an example of a reduction reaction. And we're going to spend some more time here talking about reductions in general, especially when they produce alcohols. And when we talk about gaining of hydrogen, certainly that can happen by directly reacting carbonyl compounds with the element hydrogen. And you can see here in the first example, the aldehyde reacting with hydrogen turns it into the corresponding alcohol by literally gaining two hydrogens, one on either end of the carbonyl. So it's similar to doing an addition reaction on an alkene, but with the carbon and oxygen at opposite ends of that double bond, the effect is to create an alcohol. And you can notice here it's already kind of underlined. When you start with aldehydes, you necessarily create a primary alcohol, because that aldehyde group has to be on the end of a carbon chain. That means when you create the corresponding alcohol, it's going to be a primary one. If you start with a ketone, like you see here in the second example, that will necessarily lead to a secondary alcohol, because that carbonyl is in the middle of a chain. That means the OH group you create is also going to be in the middle of a chain. But again, we're just adding a hydrogen atom to either end of that double bond. And I've shown the product how I did in the middle here, just to emphasize that it is literally just the addition of a hydrogen atom on either end of that carbonyl. But certainly we tend to draw our alcohols more like you see over here in the brackets. But the net effect is just to literally add two hydrogen atoms to that carbonyl compound. So if you plan ahead, you can know before you get going which type of alcohol you're going to make. If you are trying to make a secondary alcohol, then you would correspondingly start with the appropriate ketone, because the alcohol group ends up certainly on the same carbon as where that carbonyl starts out.